Hi there. Let's do some more practice problems in relationship to topic 7, which is using our power formulas as well as calculating the cost or price of electricity. So let's look at this sample problem. A gasoline powered generator uses up 15,000 joules of energy in 5 minutes. So how much power did it produce? So let me get my pen out. So when we do our calculations, we need to consider formulas. So one formula we have is power equals the energy in joules divided by the time, which is in seconds. So right away we should notice we have a time, but it's in minutes, so we're going to have to convert. So this is in joules per second. Okay, let's plug in what we know. We have an energy in joules, that's 15,000. And we have a time, we can put that in the denominator. That's 5.0 minutes. But then we also need to multiply by 60 to get it into seconds, because that's 60 seconds per 1 minute. And we can get rid of our minutes. So let's change let's simplify 15,000 joules divided by 300. So that's 5 times 60. So 15,000 divided by 300 is 50. 50 what? 50 watts. Power's in watts. Joules per second is a watt. Let's try this one. Toaster connected to a 110 volt power source has 6.0 amps of current flowing through it. How much power? Well, our other formula that we need to know for power is power also equals voltage of the object times current in amps. Okay, so let's plug in what we know. We have a voltage, that's 110 volts, and we have a current, that's 6.0 amps, and so that would be 660 watts of power. Let's try another one. This time we have a light bulb that draws 1.25 amps of current, and it's 120 gasoline power generator. How much power is generated this time? Here's our two formulas, either energy divided by time or current times voltage, and we have a current and we have a voltage, so we can plug those numbers in. 1.25 amps times voltage of 120 volts, and when we multiply those out we get 150 watts. One more. If the generator above runs for 5 minutes, how much energy will be converted into heat and light? So this time around, considering what we have, we know power is equal to energy divided by time in seconds. What do we know? Well, we know the power, 150 watts. We can find the energy, we don't know the time. So let's put in our power, that's 150 watts. And that's equal to the energy divided by the time, which has to be in seconds. So let's put that time in there. That's 5. So energy divided by 5 minutes times 60 seconds in a minute to get it into seconds. Seconds over minutes. these cancel, so let's clean up some terms here. 150 is equal to energy divided by 300. Okay, well let's divide times both sides by 300. So 300 on this side, and those equal 1, and then times this side by 300. And so energy in joules is equal to 150 times 300, which is 45. 1, 2, 3, 45,000 joules, or 45 kilojoules. 45 kilojoules. A couple more problems. Now let's talk about the price of electricity. A meter reader determines that a business has a 35,050 kilowatt hours of energy in 2 months. If electricity costs 10 cents per kilowatt hour, how much would the bill be? Okay, so this is over a 2-month period, right? And so how many hours? Well, that's used up. So what we need to do here is, let's just minimize this, and let's go to here. So this is over a 2-month period, so how much is the bill in 2 months? Let's convert this into dollars. So let's go back to full screen, get my pen out. So the price of electricity is so many kilowatts hours of energy or electricity times 0.10. And so what would that be? 0.1 times 3,550, that's $355 would be the price of the bill. Okay, an electric heater draws 110 watts. Electricity costs 8 cents per kilowatt. How long does it cost to operate for 3 days? 3 hours a day for 30 days. So let's figure out how many hours this is first. 3 hours a day for 30 days. Okay, well, let's figure out how many 3 hours times 30 days. So 3 hours every, so that's 90 hours in the month. And the price of electricity is 110. It's 8 cents per kilowatt hour. So let's figure out how many, if it runs for 110 watts for 90 hours, how many kilowatts per hour is that? So 110 or 1,110 times 90 hours, and then times that by 0.08 or 0.08 dollars per kilowatt hour. And so when we do that, we should get $7.92. $7.92 if you check your math. So there are some samples of how we might do problems related to two things: our power plus the price of electricity.